All right, today we're talking about the surface area of prisms and cylinders. So we just had our previous lesson where we introduced a lot of vocab. We're going to kind of extend on that vocab a little bit here and then practice our area and perimeters from the last unit. Now just unwrapping a 3D image to be a collection of 2D things. So let's look, okay? So first remember what a prism is, right? It's a 3D polyhedron that has two congruent bases, and those bases have to be in parallel planes. They don't have to be directly above one another to be a right prism. They could be off-centered, you know, as long as they're parallel and connected by parallel lines, they could still be an oblique prism. Okay, I like to think of this like a stack of Post-it notes. So the bottom Post-it note and the top have to be the same, whatever it is, a hexagon, octagon, pentagon, and then we just have a really tall stack of hundreds of these Post-it notes. And the stack could be a little off center, so it could be a crooked stack as long as it's parallel the whole time. So the first two words we're looking at our vocab terms are lateral faces and lateral edges. Really what this comes down to is the idea of lateral. Lateral, back from Latin, means the side. We saw this with equilateral, means it has equal sides in a triangle or, you know, polygon in general. So lateral faces essentially is the non-base stuff. So the base, think of, you could rotate the 3D object until the base is on the top and the other base is on the bottom. And then the lateral is all the other stuff as you go around. All of those four-sided figures there as we go around are the lateral faces. So if I kind of unbox this, cut up this Amazon box and opened it up, you would get the top here and the bottom here. Those would be our two bases. They have to be congruent and parallel. And then the rest of these faces would be the kind of side faces. Those would be the lateral faces. The edges, these parallel lines that connect to the bases, one at each vertex, those are going to be the lateral edges. We're not going to use that term that much. You might encounter it if you get to a word problem and it says, you know, oh, here's a prism, yada, yada, with lateral edges of length 12 inches. But beyond that, they're not going to be, you know, really important in terms of discussion. But knowing what the lateral faces are is important. Now, really the reason we talk about this is because often the way we find the area of a prism is we find the area of the bases and then we find the area of all of the lateral faces together. So down here, the next thing is we have two different terms. We're going to be looking for the surface area. So if I was painting the outside of this prism, top, bottom, every side, every face, if I was doing that, I would say, okay, I'm going to find the entire surface area of the 3D figure. That's what I'm going to paint. However, again, we're going to break that up into two regions. We're going to say, okay, I'm going to find first the area of what you would think of as the top and the bottom, or the two bases. So down here in this picture, I would find the area, this triangle on top, and then multiply it by 2 because a prism has two of the same bases. And then what I'm going to do is I'm going to find the entire lateral area as one chunk. So these three rectangles or parallelograms, whatever these are, I'm going to find all three of those at the same time. So first I say, okay, I've got my two bases, which are the same, right? So find the area of one base and multiply it by 2. And then I'm going to find this total lateral area separately. And so we'll use that term lateral area quite often. Okay, same thing over here. We'd find area of one base, multiply it by 2 to get the area of the two bases. And then we'll shade this is all the lateral area. And we'd find the area of that all at once. All right, so really introducing the word lateral, but we saw lateral faces, lateral edges, and lateral area. Okay. Now, the last new vocab term is Annette. Okay. Annette is, imagine you have a 3D figure, you take a pair of scissors, and you cut just the right amount of sides, not so it's a bunch of separate polygons, but instead so you can unfold this and lay it flat. Okay, so here, if I just cut up this Amazon box, so if I cut it along this edge, this edge, this edge, this edge, and then I need to separate the top somehow, so if I cut it here, here, and here, then I would be able to unravel this while still leaving all the faces connected into one 2D thing. So here's my, if I unwrap this, this is my 5x6 top that's opening up. So here's still my top that's still 5x6. And then I have all these heights of 2 on these sides here, 2, 2, 2, 2. This was 2 centimeters tall. So as I open it, I still get all of these are 2. They're just opening outwards instead of up now because we flattened this box out. And then we still get this bottom down here, and the bottom still being 5 by 6. So this is often an easy way for us to think about a 3D shape when we're talking about surface area. We open it up, whatever cuts we need to make so we can lay it flat on the table, and then we just find the area of a bunch of 2D polygons, which is what we did in Unit 11 previous to this. Okay, show you one more image. Here is a triangular prism. We cut along, here it looks like we cut this edge and this edge. Then we cut on the same in the back. We cut that edge and that edge. So now we could flap these 2 flaps outwards, and we get our 2 bases. And then to undo our lateral faces, we just cut right here on the top. And that way 1 flap goes this way and 1 flap goes that way. And so we get another net of our other 3D polyhedron here. Okay, so that's what a net is. And again, we're going to draw sometimes the original 3D shape, and sometimes we'll draw the net, and might even ask a question like, what polyhedron would this net form? Or find the surface area of this 3D polyhedron based on the net shown. Things like that. Okay, now I really want to remind you of one thing, because I say this next reminder is really probably one of the 2 most common mistakes I come across. Actually, this is a good one. The other really common one I come across is if I set up a triangular prism here and I say, okay, you know what? What's the volume of this? What's the surface area of this? The first thing somebody needs to do, whether they explicitly say it, or write it down on their paper, you need to say, what shape is this? Right? What polyhedron is this? And a lot of people will say, oh yeah, this is a prism. And what type of prism? And they will say, well, the bottom is a rectangle, so this is a rectangular prism. But that's not true. If it was a rectangular prism, you would have a rectangle projected through to another rectangle, so it would look like a shoebox. This does not look like a shoebox, so it's not a rectangular prism. The shape projected through is a triangle. So first common mistake is people just arbitrarily choosing the bottom to be the base. The base shape has to be what shape is projected through space without changing. If I cut this over and over and over and over and over, parallel the base, I get the same triangle every cut. No matter where I cut it, I get the same triangle all the way along. Now that's why it's a triangular prism. Okay, so that's error number 1. Error number 2 is people really have a difficulty finding the height of a prism. Now, I want to be really clear that, remember, the base and the height need to be perpendicular. So in general, the way we think of height, and this is really important, is the height of a prism is the distance between the base shapes. Remember, the 2 bases are always parallel, whether they're right above one another or not. So in the picture up here, I say, well, it could be a right shape or an oblique shape. But again, the height is, no matter what orientation this prism is in, it's the distance between the 2 bases. Now, if I go up here, a lot of people in this picture, right, just looking at this last shape we had, a lot of people look at this and they say, oh, the height here is h. And sure, that's the height of the triangle, right? So you use that in like 1/2 base times height to find the area of the triangle. But what's actually the height of this prism? The height of this prism, talking about if I want to find the volume of this prism, if I want to find the surface area of this prism, the height of this prism is from here to here, which is the same as from here to here. Assuming this is a right triangular prism, this would be the height of the prism. Okay, now if it was oblique, if it was slanted like down here, then that edge is not the height. You have to find this height, you have to find this height that is perpendicular to the base, okay? Now, in a problem, I would be very clear whether it's right or oblique, whether or not, like in this one on the left, since these are perpendicular, since it's standing upright, the height is just this edge, right? From this bottom base going up to the top base, The distance between those bases is just this lateral edge because they're perpendicular. So I would say that is by far the second most common mistake when looking at 3D shapes is what is the height of my prism or, pyramid, cylinder, cone, and not being able to see that it's from the base perpendicular up to the other base. Okay. All right. So now that we've got that down, let's look at what shapes are the lateral faces. Okay. So if I cut up this triangular prism here, what I get are, and I'm going to draw this out. Okay. So what I get is and I'm going to cut with pink. Okay. So I'm going to cut along here and cut along here. I'm going to cut along here and cut along here. So I can flap those down. So what I get, they have to be congruent. So I get this right here, which is 5, 6, 3. And up on the top, that flaps down also. So I get a 5, 3, and a 6. Okay, so they just flapped outwards. I need to make one more cut. So I'm going to cut along this edge here. And let's say this is a right triangular prism. Okay, so now that I flap this outwards, I get that this is, and it was at a right angle, because I said it was a right prism, so these are all right angles, right angles. So as I flap that outward, I get this 10 is here, flaps outwards to, this is the 3, right? That was a 3 here, 3, there's a 3, and a 10. Flapping out the other side, this flap is 6 long, because it comes over from here. And 6 long, and 10. And this just takes some practice to get used to. Okay, so now if I wanted to find the surface area of this, I would say, okay, well, I can find the area of my base, right? Here's the area of my base. I can multiply that by 2. But the question is, how could I find, in one fell swoop, the entire lateral area here? Well, what is the lateral area made up of? The lateral area is made up of this shape here that was all rectangles, and this shape over here, rectangle, 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 rectangle. If we add all those up, we get, this is lateral area, 1 rectangle, right? And what are the dimensions of this 1 rectangle that we just opened up? And this is of any right prism. If we open it up, we get a rectangle. So let's look. On the bottom, we have 6 plus 5 plus 3. So yeah, that could seem a little specific to this problem, but in general, 6 plus 5 plus 3, 6 plus 5 plus 3, that's the distance around this shape. So that is just the, down here, I'll do it in pink, this is the perimeter of base shape. Whoops, a base shape. And then what's this? This is the height of prism. So the entire area, the lateral area, I'll call that LA for lateral area, is just the perimeter of the base times the height. That's it. That's our rectangle done. Now, let's say, okay, that was easy, right? We opened up, it was already rectangles, it was made for us. Let's say, and I did a terrible job drawing this, but let's say we have an oblique prism now. So now the height does not match there. Well, let's see. If I cut this up, I cut, and let's say these are rectangles drawn in 3D. I know I did a terrible job here. Cut, right? We cut along here. That'll open it up for us. So what we get is, we get a rectangle on the bottom, we get a rectangle on the top, right? Oh, sorry, it's oblique, so they're not above one another. This is off-centered, okay? But they're connected by parallel lines. So it's connected here. One flap comes out this way, still connected by parallel lines, right? And then I don't have this space to draw a lot of these, but I'll draw it like that. And so what do we get? Well, we know that the two bases have to be parallel, right? That's part of what it is to be a prism. The two bases have to be parallel. And we know that the bases are connected by parallel lines. So all of these have to be parallel. So look at this. These are all just parallelograms. And remember that the area of a parallelogram is also just base times height, just like a rectangle. Now, the only difference here is the height is not the edge, right? The height is not, well, let me do this in a different color. The height is not the lateral edge. So the height instead is something separate outside the figure from the top base to the bottom base. What is that distance? Okay, so either way, we end up getting, this is the perimeter of the base, and then we just multiply it times whatever this height is. And we don't know what that height is. We'll have to figure it out in some problems, or it might be given to us in some problems. So what we get for the surface area of our prism is we simply just find what's the area of our two bases, and then we add up the lateral area, which is simply the perimeter of the base times the height. So clearly saying the capital B stands for the entire area of the 2D base shape. Could be a triangle, pentagon, whatever it is. Capital P stands for the perimeter of the 2D base shape. Again, that could be a pentagon, hexagon, whatever it is, but the perimeter of the base, that's what P stands for. And then H stands for the height of the prism. And again, that is, just to rewrite it again, aka the distance between the bases. Okay, so let's do our first problem then using this formula. Okay, so surface area of a prism, we've got a regular pentagon here. It doesn't show us that the angles are technically the same, but let's make that assumption here. So what we've got is, for sure I know our surface area is equal to 2 times base plus perimeter times height. Okay, now I know that this is my base. So if this is my base, then what I've got is 2, I don't know that area, I'm going to have to figure that out, plus the perimeter of the base, which is just 10. Okay, right, that's 2 times 5. There are 5 sides, each one's 2. Times the height of my prism. Now the height of my prism is this 3.15, because that's my distance between the two pentagons. There's a pentagon in front, and there's this pentagon in back. And those two pentagons are 3.5 inches apart. So it doesn't matter that this is horizontal or vertical or what direction, because I could take this same object and stand it on its pentagon base. I could stand it on one of the lateral faces, which are rectangles here. It doesn't matter which way you stand it. It's still going to have the same surface area, the same volume, the same name. So the difficulty here is I got to find the area of the base. Okay, so off to the side, I'm going to say, well, how do I find the area of a base? Well, that's a regular pentagon. So from our last unit, we know we're going to find that by finding the apothem, because we know the area is 1/2 apothem times perimeter, or 1/2 whatever that apothem is times the perimeter of 10. Okay, so doing a little solving here, I go, oh, the central angle here, since this is regular, is 360 divided by 5. So we start with a triangle that looks like this. 2 on the bottom. These are congruent, and we have 72 degrees. So I cut that down the middle, and I get a half of that triangle, which is 1A and 36 degrees. So I go, okay, well, that means the tangent of 36 degrees equals 1 over A. Rearranging that or solving is multiplying by A, dividing by tangent. I get that A is 1 over the tangent of 36. Okay, so putting that over here, 1/2 times 10 is 5 times whatever this apothem is. So I get 5 times 1 over tangent of 36. And I'm going to keep it as exact for now. If you want to punch that into a calculator, you can. So I got the area of my base was 5 over tangent of 36. Going back over here, that's 5 over tangent of 36. It's not going to get much simpler. I'll simplify it a little bit, but that's going to be 10 over tangent 36 plus 10 times 3.5 is 35. And then you could approximate that if you want. I'm going to leave that as an exact answer. You could punch that into a calculator. Okay. Now, I want to mention, now cylinders really are just prisms. They're just circular prisms. We treat them essentially the same. We use all the same formulas for surface area, lateral area, volume. Everything we do, this is essentially a prism. The only reason it's not is because of the curve. It's technically not a polygon as the base. It's not made of polygons of flat surfaces. There's these curved warp spaces. So we technically don't say it's a prism. However, if we open it up, it's still just two bases that are both circles. And still when we open it up, I mean, think about just, you can take any sheet of paper in front of you and just curl it up to make a tube. If you open up the paper, it's a rectangle. If you curl it up, it's a cylinder, or at least the lateral face of a cylinder. So if you open up that lateral face, the top here is just the perimeter of the base, aka the circumference of the circle, right? Curl it up, yeah, the top edge of the paper is the distance around a circle. Open it up, now it's the width of my rectangle, and then this is the height of your cylinder. So we still get the exact same formula here. The only difference is I changed it in pink here. You just go, well, instead of a prism, this is for a cylinder, and then all you do is say the perimeter of a circle is called the circumference. So you just say C here instead of P, and instead of P you say C is for the, instead of perimeter, circumference. So I just highlighted in blue in pink the only things that change, but essentially it is the exact same formula for a prism and for a cylinder because they have the same thing. You essentially just have, boy, now this is going down a rabbit hole, but you essentially just have an infinite-sided regular polygon, and then there's, depth and beauty to that. But yeah, it really is like a prism. Okay, so let's just walk through a bunch of examples. That's the lesson. So find the surface area of the solids formed by the net. So first of all, if I put this together, I would see that this is a cylinder like this, where we have a radius of 2 and a height of 10. So I know that the surface area of any prism or cylinder is just 2 times the base plus perimeter times h. If you really want, you could use the C for circumference. Now I'm going to go in and plug in my formulas. Well, the area of a base is pi r squared. The circumference of the circle or perimeter of the base is 2 pi r. And then times h. So now I know I've got 2 pi 2 squared plus 2 pi 2 times height of 10. So that's 8 pi plus 2 times 2 is 4 times 10 is 40 pi. So I get that the surface area is 48 pi. Okay, over here, if I fold this other shape up, what I get is a triangle on this side, a triangle on this side, and then connected. Oh, that should have been dashed over there too. Let's erase that. And so let's mark what we have. This is equilateral with each side 8, and then the height between these is 20. So again, we say, okay, well, that's the surface area is 2 times the base plus perimeter times height. I can already know that the perimeter of my triangle on the bottom, it has to be, your bases have to be the 2 congruent shapes that aren't the rectangles or the parallelograms in the middle. So the perimeter is 8 times 3, or 24, times the height of the prism, or the distance between these two bases. Distance between was 20. And then again, all I got to find is the area of that base shape. And that's pretty common to be the hard part, okay? So I know the base of my triangle is 8. I just got to find the height of this. I'm not going to use the 1/2 AP. I could do that because this is technically a regular shape. But with a triangle, I think 1/2 base times height is easier. So equilateral triangle starts with 60 for all 3 angles. If I cut it in half, that's 60, 30, 90. So I know that half the base is 4. So what I end up getting is this right triangle where it's 30, 60, 90. This bottom part is 4. And what I'm looking for is h. So you could absolutely use trig. I'm going to say that this is similar to the 30, 60, 90 I have memorized. And that 30, 60, 90 is 1, 2, root 3. And I would go, oh, well, you know what? This is just 4 times as large as my triangle. So this is 4 root 3. So I can go back here and say 4 root 3. So the area of my base is 1/2 base times height, or 1/2 8 times 4 root 3. So this would be 32 root 3, and half of 32 would be 16 root 3. So I'm just going to go back over here and go 16 root 3. So simplifying this a little bit, I get 32 root 3 plus, and that would be 480. And you can't simplify that any further unless you punch in a calculator to approximate it. But that's the simplified exact answer. Okay, let's look at a couple other problems. So now just applying it, here's a cylinder. It tells you the radius of the top is 0.8. It tells you the height here is 2. So we got surface area is, just making sure it says round to 2 decimal places. Okay, so we got 2 times the base plus perimeter times height. So that's 2 pi r squared plus 2 pi r for the perimeter of the base or the circumference, and then times height. So plugging in these numbers, I got 2 pi 0.8 squared plus 2 pi 0.8 times 2. And so we get is, I'm going to do it over here, I get 2 pi 0.8 squared plus 2 pi 0.8 times 2. Let's see if that worked out. There we go. It all worked out nicely. So 14.07. So this is around 14.07. Okay, so the next one says, okay, enough just plugging in the formula and going forwards. Now let's go backwards. Okay, so this one gives us the surface area and says, let's go backwards. So now notice with a rectangular prism here, I could choose any face to be the base. I could choose the bottom to be a base because it's projected all the way through the shape. I'm going to choose this front one as the base. Okay, it doesn't matter which, but because it's a rectangular prism, any rectangle could be projected through to the back or the top. So I'm going to choose the front and back to be the bases. Okay, so when I say surface area is 2b plus pH, it might look a little different than yours. You'll still get the same result. So plugging this in, I get that my surface area is 606 is equal to, now this is 2 times the area of my base that I chose is 7 times 15, plus the perimeter of my base that I chose is 7 plus 15 plus 7 plus 15, and the corresponding height from my base to base, the distance between my two bases, is x. Now if you chose a different orientation, for sure you could have had the area of your base being 7 times x, the height being, that'd be capital B, the height being 15, and that'd be if you chose the bottom as the base. Now I chose a different base, so it doesn't matter. Okay, so all you get here is 606 equals, this is 210 plus, that's 22, that's 44x. And then it just becomes an algebra problem to unwind or solve backwards. So minus 210, minus 210. That's 396 equals 44x. Dividing by 44, we get that x is 9. And then just double check, it says solve for x. So that was it. So in the next one, let's do this again. I'm just going to start this one. I'm not going to go all the way through it with you. So there's a base that has to be the triangle. So it's a triangular prism. It's the first thing to identify. It's like, okay, surface area is 2 base plus perimeter times height. Well, let's start out. I know that the total surface area is 616. The area of the base is 1/2. And because 8 and 17 are perpendicular here, I say, yeah, it's 1/2 times 8 times 17. Plus, oh, we don't know the perimeter. And then times the height, and the height here is x, because that's the distance between the triangles. So what we need to do is look at this triangle and find the perimeter, 8, 17, and question mark. So we just use 8 squared plus 17 squared equals c squared to find what c is equal to. And then once we get that, we put it over here. So 8 plus 15 plus whatever you got for C, right? That would be a number that you would calculate right now. And then that just becomes a linear equation, right? That'll just be, this equation would be analogous to 5 equals 10 plus 3x. You would just have a more complicated number here because it will be a decimal. But other than that, it's just a normal linear equation. You're going to solve it as is. Okay. So let's go on. The radius and height of a right cylinder are each divided by square root of 5. What is the change in surface area of the cylinder? Now I bring this up because this is similar to some work we did before. So what it's saying is we had a big circle and this, and then a big circle. So we had the lateral area and everything. So radius, here's 2 pi r, and here's h. So what it's saying is the radius and the height are both divided by 5. So this gets divided by root 5. The r gets divided by root 5, but since this is just a number, that's still just this whole thing divided by root 5. And we get this is divided by root 5, and this is divided by root 5. So what we get is similar shapes. It'd still be a rectangle, it'd still be a circle, it'd still be a circle. All of those individually would still be similar. But what we would get is we would get a 1 to 1 over root 5, or a root 5 to 1 ratio of sides. And if you guys remember, what does that mean for the ratio of areas? We take that ratio of sides, that scale factor, and we square it. And that means we get a 5 to 1 ratio of areas. And what that means is the change in the area is it got divided by 5. So got divided by 5. And that comes back to the idea, if you shrink, and that's like, the same idea here. If I take this 1 by 1 rectangle and say, oh yeah, the area is 1, and I cut it in half one way and in half the other way, so both dimensions get cut in half, you don't just multiply the area by 1/2. It's because this base got multiplied by half, the height got multiplied by a half. So when you go area equals base times height, you have a 1/2 times 1/2. So you actually multiply the area by 1/2 squared because each of the two dimensions got halved. So half times half, we actually get 1/4 of the area, right? 1/4 of the original rectangle. So that's a big picture idea we had. So bell's going to ring, ignore the bell, do maybe 1 or 2 more examples. Okay, so find the height of a cylinder with a surface area of 108 square or 108 pi. Okay, so we know the surface area is 108 pi. It says the radius of the cylinder is twice the height. So we know that the radius is equal to 2h. So I'm going to go over here. I'm going to draw my cylinder. Okay, so I got a radius and a height. Well, I'm just going to go at it. So surface area equals 2 times the base plus perimeter times height. So that's 2 pi r squared plus 2 pi r h. That's the surface area. So now plugging in everything we have 108 pi equals 2 pi r squared plus 2 pi r h. Now, because we have r equals 2h, we could swap out and solve for either r or h. Let's see which one we want to get rid of. It says find the height. So we want to get rid of all the r's. So let's put that in wherever we had an r. Just substituting it in, we get 108 pi equals 2 pi, and the r, the entire r that's squared, gets replaced by 2h. So that's both the 2 squared and the h squared, plus 2 pi 2h times h. So what we end up getting is 108 pi equals, this is 8 pi h squared, plus this is 4 pi h squared. So we could combine like terms. These are h squareds and h squareds. So we get 108 pi is equal to 12 pi h squared. Now, really, this is just like 3x squared equals, 12. We just want to get rid of that number next to the x squared. So we're going to divide both sides by the 12 pi. It's just a number. It's around 36. So if we divide by that, we get h squared is equal to, and that's 9. Now just square rooting both sides, you would normally get that h equals plus or minus 3 when you take a square root. But of course, since we're dealing with the height of a real 3D shape, it can't be negative. It has to be positive 3. So we get a height of 3. Okay, so this last challenging problem I will do, again, totally optional. I like to throw in extra stuff here. So the ring shown is a right cylinder of radius r1 with a cylinder hole of r2. Okay, find the surface area of this. So let's think about this in general. What are we going to get? Well, let's start with, we're going to have the surface area of the big cylinder. Okay, so we're going to take the surface area of the big cylinder. And then what are we going to do? Well, I'm going to think we're going to take away a hole on top and bottom. So we're going to take away 2 holes. Okay, and that's on the top. We took away this chunk. And on bottom, we took away this chunk. Okay, so we take away 2 holes. So we got the original surface, and we cut a hole in the top and bottom. But also, we didn't just get that. If we're painting this entire surface, right, then let's see, we need to also get what is this lateral area on the inside of this cylinder. That becomes an exterior surface. So if it's saying to find the surface area of the whole thing, we're going to have to then add in the lateral area of smaller radius. And that's, I think, the part that a lot of people forget about this problem. So I can go through and solve this all the way through if people want, but right now I'm going to stop as is.